Hello student, now we will discuss application of Byte and Savret law. Applications of Byte and Savret law. The next application is magnetic field due to current carrying wire of finite length. Suppose this is a wire of length DE through which current is flowing in the upward direction I. Let this is point P where we have to find the magnetic field due to current carrying wire. The length of P from current carrying wire is equal to A. That is OP is equal to perpendicular distance of point P from current carrying wire DE. Join DP which makes an angle alpha with the direction of flow of current, and join EP which makes an angle beta with the current carrying wire. Let at point M a very small element of current carrying wire of length vector dl. The dl vector is the direction of dl vector is along the direction of flow of current. Join MP which makes an angle theta with the direction of flow of current. MP vector is equal to R vector, or we can say R vector makes an angle theta with the vector dl. Suppose at point P the magnetic field due to small element dl is dB. That is, suppose dB is the magnetic field at point P due to small element of current carrying wire. Let OM is equal to minus L. OM is equal to minus L. O is origin. So below origin length is negative and above origin length is positive. According to Byte and Savret law, the magnitude of magnetic field at point P due to small element dl of current carrying wire is given by dB is equal to mu naught upon 4 pi into I dl sin theta upon r square, where mu naught is constant called permeability of free space. Put this question number 1. To find total magnetic field due to current carrying wire, integrate the above equation both sides. Therefore, integration of dB from 0 to B, B is the magnitude of total magnetic field, equal to integration from point D to E of mu naught upon 4 pi into I dl sin theta upon r square, or integration of dB is equal to mu naught I upon 4 pi into integration from D to E of sin theta dl upon r square, as mu naught I upon 4 pi is constant and we can take it out. Put this question number 2. Now in integration, there are 3 variables theta, L and R. So we convert it into only one variable theta. In triangle OMP, this is triangle OMP, that is right angle triangle OMP. MP, which is hypotenuse, upon OP, which is perpendicular, and it is equal to cosecant theta, that is hypotenuse upon perpendicular is equal to cosecant theta. This implies R upon A is equal to cosecant theta, as MP is equal to R and OP is equal to A. Or this implies R equal to A cosecant theta. Put this question number 3. Similarly, OM, which is base, upon OP, which is perpendicular, and it is equal to cot theta. This implies minus L upon A is equal to cot theta, or minus L is equal to A cot theta. Put this question number 4. Differentiate both sides, we get minus dl is equal to dA cot theta, that is derivative of A cot theta. Now A is constant, so we can take it out. Therefore, minus dl is equal to AD cot theta, mean A into derivative of cot theta, or minus dl is equal to A into minus cosecant square theta into d theta, that is derivative of cot theta is minus cosecant square theta into d theta due to chain rule, or minus dl is equal to minus A cosecant square theta into d theta. Now minus and minus cancel each other, so we get dl is equal to A cosecant square theta into d theta. Put this question number 5. Putting these values in equation 2, we get integration of dB is equal to mu naught I upon 4 pi into integration of sin theta into A cosecant square theta d theta upon A square cosecant square theta. As theta is angle between dl vector and r vector, therefore at point D, theta become equal to alpha. Theta is equal to alpha. So lower limit become alpha, because when we substitute or we integrate by substitute, the limit also changes. So lower limit becomes alpha. and at point E. This is point E. This is the direction of vector R and this is the direction of dl vector. So angle between these two vectors become pi minus beta. So theta is equal to pi minus beta. So upper limit becomes pi minus beta. Therefore, integration of dB is equal to mu naught I upon 4 pi into integration from alpha to pi minus beta of sine theta into a cosecant square theta d theta upon a square cosecant square theta. Now in the numerator, a cancel with one of the a in the denominator. In the numerator, a cancel with one of the a of a square in the denominator. And cosecant square theta cancel with cosecant square theta. Therefore, we get B is equal to B is the magnitude of total magnetic field and equal to mu naught I upon 4 pi into integration from alpha to pi minus beta of sine theta upon A with respect to theta, or B is equal to mu naught I upon 4 pi. Now within the integration, A is constant and we can take it out. So we get B is equal to mu naught I upon 4 pi A into integration from alpha to pi minus beta of sine theta with respect to theta, or B is equal to mu naught I upon 4 pi A into minus cos theta, and lower limit is alpha and upper limit is pi minus beta, because integration of sine theta is equal to minus cos theta, or B is equal to minus mu naught I upon 4 pi A into cos pi minus beta. That is, first put theta is equal to upper limit pi minus beta. So we get B is equal to minus mu naught I upon 4 pi A into cos pi minus beta minus put theta is equal to lower limit alpha. This become minus cos alpha, or B is equal to minus mu naught I upon 4 pi A into minus cos beta, because cos pi minus theta is equal to minus cos theta and minus cos alpha. So by solving this, we get B is equal to mu naught I upon 4 pi A into cos beta plus cos alpha. That is, when we take minus common, it cancel with minus in the outside. Hence, B is equal to mu naught I upon 4 pi A into cos alpha plus cos beta. So this is the magnitude of magnetic field due to current carrying wire of finite length, and direction can be found by right hand screw rule. So thank you very much.